You light our homes. Keep us warm.
You help us explore, innovate, and achieve the unthinkable.
You are everywhere.
Yet, sometimes out of reach.
You move us forward and bring us together.
And together, we're on a journey towards the future of energy.
So what will it look like?
It's hard to say, but we know it will be sustainable and abundant.
We're already on our way.
With a common purpose, each of us playing our part.
At Deloitte, we're connecting every bright mind, every organization, every startup, every innovator.
Every citizen, CEO, and regulator.
Making this future happen won't be easy, so we're developing practical solutions.
And a clear roadmap to help our clients on their way.
We'll keep making those connections
Each step well planned, moving forward together.
to make our new energy future a reality. Let's connect for a new energy future.
Ladies and gentlemen, the title of this panel is Hydrogen Technologies, R&D and Application. It's a wide-ranging topic, but I am convinced that the panelists who are with us here today, that their competences allow us to approach this very wide-ranging subject, because we're representatives of science, of business, as well as representatives loosely connected with industrial business applications. In December 2021, in Monitor Polski, Polish hydrogen strategy was published, strategy until 2030 with perspective until 2040. This is the title of the strategy. And the Polish hydrogen strategy is a strategic document. This is essential, which defines the main goals of hydrogen economy in our country and directions of development necessary for the achievement of these goals. Here we have distinctions into global, European, and national developments and steps, measures aimed at building a low-emission economy. 6 main goals were established in the document. However, in today's discussion, I'd like to concentrate on one of the selected goals, number 2, in fact, which says using hydrogen as alternative fuel and transport. Certain indicators were also defined for that goal, and until 2025, the main indicators are initiating using zero-emission buses propelled by hydrogen in the number of 100 to 250, development of fueling stations, in other words, I would say construction of fueling stations, and in case of our country, minimum 32 such stations, and construction of hydrogen trains, hydrogen locomotives, which will replace their internal combustion alternatives in non-electrified routes. Until 2030, it was expanded from 800 to 1,000 when it comes to buses. We assume that some of these buses will be produced in our country. Further development of infrastructure, a gradual replacement of standard locomotives with their hydrogen alternatives, and development in road transport, inland transport, intermodal, air transport, generally transport, generally speaking. So, another document also was created. Here I'm talking about sector agreement, which was signed by the signatories of this agreement in October 21. And this document is very significant because it constitutes an executive instrument of the Polish hydrogen strategy. And in that document, as strategic goal number 1, that is in fact the leading thought of its creators, was local content, that is Polish input. I've selected one of the topics here, construction of research infrastructure for researching hybrid propulsion systems with hydrogen elements for marine, road, and rail transport here. And here my question goes to Professor Piórkowski, who has learned from practical side very well the construction of the technological side when participating in foreign projects. I'd like to ask, do you find actual room for completion of such strategic goal when it comes to Polish input in this type of energy? Professor, what's your view here? Good afternoon. Answering your question, yes, there is such a place, such room for Polish content in propulsion system with fuel cells. If we are talking about means of transport, we are talking about low temperature fuel cells, PDM type. There are other types used, for example, in the energy sector. These are high temperature ones, which work in a stable manner. But in transport and means of transport, we concentrate on low temperature fuel cells. We have certain problem here that as far as fuel cells alone, I hope I'm mistaken, but I think that's my feeling anyway, that in short or mid-term in Poland, we will not have Polish production of Polish fuel cells of low temperature type. I'd like to be mistaken. However, production of such fuel cells is highly specialized, and it requires a connection of many tests, research. This takes dozens of years. I remember first research conducted in one of automotive concerns back in 2003, 2004. So it's a long-term process, the building of knowledge, experience. So in short, mid-term, for fuel cells alone, I think it will be difficult to introduce this local contact. However, let's remember that fuel cells, they are not everything that's there. The fuel cells have to be accompanied by other components which allow the fuel cell to work properly in propulsion system. And here we have, and very briefly, of course, not to bore you, we have an air compressor. It's simple, right? Air compressor, but in reality, this air compressor has to be very dynamic. It has to react in a very dynamic way to changing load. Otherwise, if it were working at its maximum all the time, then the entire fuel cell systems would be characterized by very low efficiency and very high hydrogen consumption. Another issue, energy electronics, the compressor needs to be supplied. So we need appropriate inverters. Another example, DC inverter, because the input voltage changes depending on load. This characteristic is non-linear. However, at the exit point, we want to have a fixed value of constant voltage. It has to be stabilized as well. And other elements, something quite simple. For example, air filtration. Fuel cell has to be provided with pure, cleared air, because any sort of pollution will cause quick degradation of such fuel cell. Filters are used, not just mechanical filters, but electrostatic filters, so it becomes quite complicated. Diagnostics systems. Diagnostic system, in my view, is one of the most important elements because it is decisive when it comes to safety of the fuel cell, so that the usage of this means of transport propelled by hydrogen can be safe. We have to constantly scan the quality of membranes in fuel cells. These are very advanced systems as well, so we can keep listing such elements. I don't want to do it here because there's no time for that, but it just illustrates that this ecosystem is very expansive. We can find many companies here who could introduce such content, such varied content. For example, we can see on the example of electric buses. There are many Polish companies which build components for electric buses, but let's not just talk about hardware, because that was hardware, what I've mentioned. In addition to that, we have selection of components, because it has to be customized. Every vehicle has a different mode of travel. We have to select appropriate size and type of fuel cells. The shorter the series, the more often you have to select. So in Poland, we generally have a chance because we deal with niche products, such as buses, such as locomotives, which are built for concrete customers. So that selection is much more frequent in the case of passenger cars, and also control. So know how to control it, how to steer it. This cannot be bought. This has to be worked out. This has to be developed, has to be constructed. So coming back to your question and wrapping up, yes, there is place for local content, but we need specific tools, special tools. It cannot be done in your garage, proverbial garage. These are high technologies which require a lot of input, a lot of expenditures, not just in research infrastructure, laboratories, but also in professional, properly trained human resources. Thank you very much. So as I can hear, we have a lot of places here where we can be active. Bydgoszcz company PESA is a great example of building a demonstrator project fueled by fuel cells. Director, could you tell us from your perspective, from the perspective of successfully concluded project, how do you see this strategic goal? What should be the participation of Poland in this type of projects where our share in hydrogen in transport can be effectively increased? This area that Professor has sketched out, I would increase it because we're not thinking about the vehicle itself. to be operational needs also, of course, fueling stations, supplies of hydrogen, and also something many of you don't realize, rail hydrogen vehicles require special systems of safety, sensors, alarm systems in halls, in storage depots. So it goes beyond the vehicle itself, and it allows us to expand possibilities when it comes to Polish content. When we started our hydrogen project 3 years ago, we had a business goal to build a demonstrative locomotive, test the hydrogen model. This was one of the phase of development in building passenger vehicles propelled by hydrogen. It seemed that we found our niche, that this hydrogen maneuvering locomotive is going to be a commercial success. So we know because already we have orders, quite intensive talks. However, we are business oriented. So our goal was business oriented, building a vehicle. Now, due to certain time constraints, competition, market situation, we select partners here, so you can be the winner in this race. So the problem was that on the Polish market, there are no key partners on Polish market, and that's why we've cooperated with ABB, with Wackington, with Ballard. We've selected the best possible partners. We're also talking with Toyota, and it's not because we don't want Polish companies here, but because in our business race, in order to reach our goal, we need to go commercial. We need to be quick. So on one hand, we have a dilemma. We are waiting for Polish solutions. We're, of course, talking with Polish institutes. We know what Polish Institute of Energy is doing. We're talking with Azoty. We know that there are, certain ideas. We know that Polish producers of tanks are to be here and soon. So we're waiting for it. And so it's all about components. If they do appear on the Polish market, if available inexpensive components of Polish production, which will guarantee such companies as ours use of such components, will definitely reach for them. On the other hand, we are a bit romantic as well, and we want to work with Polish institutions, Polish entities. Here we have both good examples and bad examples. For those of you who forget about this business perspective of ours, I'd like to say that sometimes we don't have the time to learn research projects, 3-5 years, commercialization even longer, and in the time competition is running ahead of us. So until that product is not checked, until the component is in the vehicle actually, until it's not checked practically, well, we reach for foreign components, foreign competition, because we simply don't have choice. Of course, we would like to have more Polish input here, but simply it's not possible. Consequences of our experiments with Polish components ended, for example, with many millions of fines, penalties, because the vehicle was not successful. It was not meeting requirements. It turned out that together, not just the scientists, but our engineers and our partners from Polish institutes, we've made mistakes, which later resulted in 10 millions of penalties because the vehicle simply was not working the way it was supposed to do. So there are certain risks we simply have to take into account. We talked with various institutions, definitely, and many producers in Poland. We are definitely open. Anybody who comes to us, if they want to produce tanks, if they are working on fuel cells, we tell them what we need. We're going to need in 5-7 years. What are the parameters? What are the expectations of clients, of the actual power of the vehicles? We are open to it. We share our knowledge. We share parameters about requirements of these components in order to be able to introduce this Polish content in these vehicles. I'd like that bad prediction to not come true, and I want Polish fuel cells to appear as soon as possible. And I'm keeping my fingers crossed here for those who are working, and especially also with tanks, because tanks probably will appear as first.
I'm sure that, as we've heard before, we can produce, but we should invest in the first place. We should start working on it right away. And I'm sure that the contribution we've just heard is very important. So we will hear this voice in the market telling we need these products, and then the producers will respond. The question is whether it is the right moment to invest. The investment seems to be rather big, so it appears that the moment has come. I believe that, well, the 3 years of studies, this is something that cost us around 20 million zlotys, just to give you a picture. These are our own resources as those of a company without any support. We bore and incurred these expenses knowing that we need to find some more place for our products in Europe. Yeah, high technologies definitely require investments. Absolutely, I know it based on my experience of my company. In the Polish sectoral agreement concerning hydrogen economy, there is a strategic goal number 2, research and development. And here, quote, we have implementation of R&D and basic studies on PEM-type fuel cells. They concern transport, as we've heard from Professor Piórkowski, and working on hybrid drives with fuel cells to increase their efficiency and safety. This is something that is very close to my heart. I very often say that it is the hybrid that has contributed to the development of hydrogen-based drives, and the experience of studying energy flows, efficiency of hybrid arrangements, including those with fuel cells, surely is something that POZNAN University of Technology can boast about. The studies carried out, as headed by Professor Ireneusz Pielecha, justify me asking him a question about the existing barriers behind implementation of such study projects. Is there any transfer option for those study research to be used in hydrogen technologies in practice? So is it possible to commercialize the results of your studies? Good afternoon, ladies and gentlemen. Thank you very much for this question, although I need to say that, well, beginning my answer, I need to say that hydrogen drives that are available now are typically hybrid ones too. It's difficult to count them as clearly electric ones because you've got this battery, additional energy tank that is there on the vehicle. But back to the main part of a question concerning the studies. Of course, our studies, as well as other works, can be divided into 2 groups, the basic ones, and also, to a larger extent, the ones that we deal with, the operation ones. Professor Piórkowski has already mentioned that it is difficult for us to refer to those basic studies because we do not produce such fuel cells or single components of such fuel cells. Maybe we don't do that yet. But for this reason, we cannot really tell you much about those basic research. We can tell you more about operational ones concerning hydrogen drives. First of all, currently, we put emphasis on hydrogen drives, but actually with the use of fuel cells. It is hard for us to talk about conventional drives, well, using hydrogen in the engine, in the combustion engine yet. But back to fuel cells, we can say that, of course, certain experience we have. It is difficult to show it to you online, but I can look at Dr. Szałek, and actually cooperation with Toyota is something we've been developing for some time. In terms of the operational research, we can get some feedback as producers. Our partners can count on our feedback in our research papers. We can talk about operation studies, but also about model studies for some smaller units, smaller arrangements of a lesser power, not a few hundred kilowatts. So let's say around 100 kilowatts, like the ones in Toyota Mirai, but also on smaller ones. Those operation studies are mostly focused on endurance of fuel cells, their durability. We can say that this is hard in itself because those drives are not really old in terms of their age, so we cannot talk about the experience of multi-annual studies on the operation of vehicles using them, but we can talk about operational conditions of such drives, hydrogen drives, particularly in terms of the typical Polish cities or typical traffic congestions. If we take into account another issue concerning the durability of the drives with fuel cells, that's one thing we can take into account, but we can also measure the response rate. So the time within which there is a response of the arrangement for the issue of power accessibility. Now, based on those typically hybrid drives, we can say that we've swiftly moved on to the power flow in a hydrogen sets, as I said, with the use of fuel cells. And as you know, there is not many drives of this kind in the market, so you cannot really carry out extensive studies using a big population of such drives. But I think that those that are there contribute significantly to particular constructive conclusions to be drawn. On the part of Toyota, so the partner in the study, I can tell you that these studies are also important for the producers who have considerable experience, but this independence voice, the outcome of studies, is also an important argument that we can use presenting our case in front of different authorities, showing how the operations of such vehicles work in Polish conditions. Hydrogen at a technical university or in a R&D center, hydrogen in a laboratory building or a technical building, well, it sounds like a challenge for the scientific and technical milieus. An experience in this case is something that the Cracow University of Technology can tell us more about. That is why I would like to address Professor Marek Brzeżański and ask him what was a challenge and what was the exciting part of the experience of studying hydrogen as used in combustion engines, Professor. Ladies and gentlemen, the Cracow University of Technology is experienced in supplying combustion engines with hydrogen ever since the 80s, first headed by Professor Korciński. Initially, big, far-fetched studies were carried out. In the recent decade, we adopted a few industrial engines to power residual hydrogen from chemical industry. And we've got over 5 years of experience of operation studies of this kind of industrial engines. What is more, we carried out a number of laboratory studies in our technical university laboratories, and the word hydrogen is not frightening to us. To a majority of the society, the word hydrogen has brought about very negative associations with some considerable threat. We carried out a few months studies on the workstations for combustion engines of a big industrial engine over 200 kilowatts powered with technical hydrogen. No problem occurred. The laboratory still exists. What is more, for over 5 years in the chemical unit, 3 big industrial engines of the combined power of 1 megawatt worked in a continuous mode, and that gave us a wonderful opportunity for carrying out operational and endurance tests. Ladies and gentlemen, I do realize perfectly well that hydrogen is not an ideal energy carrier for the processes of combustion for typical combustion engines. A better carrier would be the derivatives of crude oil. But since we have a lot of technical hydrogen to use, let me remind you that Poland is the 5th or 6th producer of hydrogen in the world. So with reference to that, we can use today the combustion engines used in the industry today, of those from railway vehicles, and we can adapt them to be powered with hydrogen. Owing to this fact, also in the society, we can talk of a promotional effect. Hydrogen ceases to be this threatening, dangerous fuel, and it becomes something like propane, butane, or natural gas. Now, at the workstation in the laboratory, we have another industrial engine, ladies and gentlemen, adopted to work with hydrogen, meant for the manufacturer of power generators. In December, I wish to organize a short seminar at the University of Technology in Cracow, and I will want to show how that kind of combustion engines work with the use of hydrogen within a seminar. We also measure toxical components of fumes. As we know, the water is the main product of the use of hydrogen. Of course, nitrogen oxides can appear, but we have an answer to that as well. What is more, ladies and gentlemen, a huge advantage of using the existing hydrogen for powering combustion engines is the fact that we can use impurified hydrogen, for example, with carbon hydrates. As regards the combustion engine, it comes as no harm. It even increases the calorific value of the fuel, but it is absolutely not allowed when we use that in fuel cells. So in this intermediary stage, the use of hydrogen as the energy carrier to combustion engines is something that is a well justified choice. Yeah, thank you very much. The voice of the pioneers is very important to those who only begin to work with hydrogen. And, well, nothing to be afraid of, as we've heard. The strategic goal, I'm thinking again about the sectoral agreement concerning hydrogen economy, the strategic goal number 3 is investments, and its agreement within goal 3 envisages investments considering creating the total value chain in hydrogen economy. Using such a full logistic chain requires a holistic approach, and it is my impression that very often this is the perspective that is missing from the projects realized within particular sectors of the economy. The power of this value chain is measured by means of the power and strength of its weakest link. So tell me, which parts of this chain require strengthening in national hydrogen economy, and how should we support those weak links for the hydrogen strategy to be able to be implemented in its entirety and within the expected deadlines? Good afternoon, ladies and gentlemen. A sentimental remark first. I wish that I was with you in person, because there are distinguished speakers and guests representing the sector. And moving on to answering to your question, I'm addressing it at the fact of the Warsaw Technical University, but also Institute of Energy. In terms of the weak links of the value chain, I guess the problem is a bit more complex, because as for now, we don't have any of the chains of the value, links of the value chain actually ready. But as we've heard here, we certainly are a player in terms of hydrogen, a significant player in terms of hydrogen production. But this is something we are about to close, because we talk about producing hydrogen out of natural gas that will be slowly decarbonized. And what we are interested in is producing the renewable green hydrogen. And here there is a scope, again, speaking about hydrogen economy without safeguarding RES is something that is utopian, because without ensuring RES, we cannot really sustain the clean production of hydrogen and building hydrogen economy on it. Now, referring to the part of the discussion devoted to local content, let me mention that only having local renewable energy sources do we stand the chance to ensure our national contribution and rely on it. Because in RES production, be it using electrolysis or using biomass, the 60–70% of the raw material input used for RES comes from our local environment. So this is one of the basic links of this value chain that we need to take care of in the first place. And today, unfortunately, we have the situation in which everybody is worried about the development of hydrogen economy. What they should worry about is worry about the entire chain, as we've heard. Well, rightfully, we should also pay attention to the fact that in all the other markets, the one that produces particular goods does not necessarily transport them or store them or process them. So today, the lack of this value chain, lack of this perspective of the development means that somebody who wishes to store hydrogen has to worry of this hydrogen actually being available, and if so, where it will be available from. So this is how stage and earlier development we talk about. The thing is, what can we do to manage it? I think we are all aware of the fact, not only in Poland but globally, that taking the historic perspective, we are at the beginning of this journey. This upshot of technologies is something that is planned for 2030, 35. This is where we tangibly and realistically can see the use of hydrogen in real world on a bigger scale. The first and basic steps that we suggest and that are important, I think, is, well, this conference that already has a long tradition, the hydrogen agreement that consolidates a few hundred people on board. But moving on, there are also Hydrogen Valley that again build the ecosystem of cooperation between stakeholders. And what is missing, and what I would encourage you to discuss about, is something that, well, I don't think I have witnessed a conversation in this part of our industrial economy development, and this is the issue of attracting direct investments. Of course, we would all like to be able to build fuel cells from scratch and electrolyzers from scratch that would actually work using the same solution, or hydrogen containers or tanks. But as one of the professors said, the world has advanced so much that we cannot really allow ourselves to wait 3 or 5 years to actually accelerate the projects and then match them against the requirements of the modern world, and then run the second or third round of studies. We need to speed it up. We need to peep a bit through a hole and then implement what has already been achieved, and then try to continue deepening and expanding the existing methods. Yes, a long way to go. Certainly, we need to keep on creating the value chain. And I would like to notice one thing, and again, we've heard it in our discussion today, that Poland is Europe's third biggest producer of hydrogen, fifth or sixth in the world. But let me draw attention to the fact that it has not been reflected in the statistics, but the fact that the cars using hydrogen, or vehicles, speaking broader, only then did we actually appreciate that we were such a big hydrogen producer. So it turns out that there is transportation there, and I would like to focus on this area. For a while, we've heard about piston combustion engines already. I would like to direct a question out to Professor Piórkowski this time. And Professor Piórkowski, within the discussion among specialists about drives with fuel cells and vehicles, we talk about the scalability. Such a notion pops up. Tell me, what does it really mean? What does scalability mean? And can it really be applied in reality? Yes. It is quite an enigmatic notion, scalability. What is it? I often explain to my students that scalability is such a feature that makes it possible for us to first bring a low power, say 5 kilowatt drive to perfection. This is ideal, for example, to be used in a, well, say, golf cart of a Malex type. If we then make it bigger by a few times, we could then apply it to the bus or locomotive. But unfortunately, this is not as simple as that. For a number of reasons, small power fuels can be cooled with air, but the higher power ones have to be cooled with liquid. So it is not simply a simple multiplying task or resizing task. You need to actually build the different solutions from scratch. But there is a certain margin within which scalability can be applied. For example, learning from the experience of building drives for personal cars by sizing it up, not simply, but, well, simpler. We can size it up using the same components, multiplying them. We can then use them to, for example, be used on a car or a truck or a train engine. And this has been done. In locomotives, it is not a single module that is used, but a few working at the same time. The same goes for buses. So you can use components that have proven well in a smaller solution. You can size them up, multiply them, and then build the drive of a greater total power. But this is not as straightforward. It is not enough to combine them, switch them on. It will not work just like that. And I've experienced that myself. I have an experience of working in a moto lab. I conducted research and participated in research on a single system of a fuel cell, but next to me there was a separate space in the lab where they tested a drive composed of a few fuel cells for a bigger drive. That was, of course, well protected. I did not have direct access to it. The other study was confidential, but working on my project for several days, I saw that they came across some issues. So for those few days, I just heard some bits and pieces of information, and they told me that they had an issue because they could not stabilize the working of the system. I was much younger than I'm now. I was really enthusiastic, full of lack of knowledge, so I gave them good advice. What's the problem if one fuel cell is working? Why shouldn't 6 or 8 work? Where does the problem lie? And one of the engineers then, looked at me and explained that those 6 or 8 fuel cells were powered with air from a single compressor, a big compressor, and some minor differences with those canals through which the air was supplied, or actually the differences in geometry of those, made the fuel cells be supplied with a different volume. So each of those worked, but with a different characteristics. And that was the reason for these fuel cells to be working independently, and it was impossible to synchronize them. So back to your question now, scalability is an option, but you need to know how to apply it. You cannot find this knowledge in the books or scientific articles. This is the knowledge that you gain as a result of long-term meticulous work, making hands dirty in a lab and returning to now infrastructure. If you don't have infrastructure and staff that will have a chance to make their hands dirty in such labs, we will not be able to buy this know-how. We will have to import ready-made solutions. Professor, you've said that it is possible, but you need to know how. And first of all, you need to want to do that, right? To make it happen. Now I would like to direct a question to Professor Ireneusz Pielecha. Another topic that we read about in scientific publications is the efficiency of drives with fuel cells. Professor, what is the efficiency of fuel cells used in vehicles? That's a very frequently asked question that I also come across, and what has the biggest impact on the efficiency of the drive in an electric car with fuel cells? So we hear about the electric car here. Thank you very much. Ladies and gentlemen, we could answer with a single word, practically speaking, but I wouldn't like to speak so short. Well, we know that we don't know, but it's obvious that the fuel cell has the worst efficiency in the entire chain that we mentioned at the beginning of the discussion. So this fuel cell has the efficiency from 0 to 40–60%, but if we take into account all the components to be found there, the entire chain for the fuel cell to be able to operate within the entire system, this is the weakest link of the entire system. When we take this electric engine, we know that its efficiency is maximum 95–96%. But what's interesting, in the worst case, it is almost 80%. If you compare this efficiency to that of the combustion engine, whose efficiency is between 0 and 40-some%, I'm talking about good ones, then we can say that on average, the combustion engine reaches the efficiency of around 30-something%. So the fuel cell efficiency is even twice as big, but in the entire system, it is still the lowest efficiency within the whole system. If you take the components that Professor Piórkowski mentioned at the beginning, so converters, then you've got the efficiency of almost 100%, 90-something. And it turns out again that this fuel cell, even though it has a bigger efficiency than the combustion engine, still this efficiency in the entire system is the lowest. Well, of course, this has to do with the fact that in such a fuel cell, we have different kinds of losses. I'm not going to get deeper into this topic because that's not probably what is needed here. But owing to those losses, we can say that the efficiency of the fuel cell, well, we try to increase it, but sadly, it is somewhat lower than that of the other components.
In order to talk about appropriate parameters of such a system, we have these high and low temperature fuel cells. We have temperature jumps. So due to the temperature, obviously, the temperature is in fact the factor that determines the efficiency. Of course, we also have to take a look at these fuel cells as a generator of current, electric current. So it would be good to have this fuel to work at one working point at fixed voltage. Of course, we get the appropriate amount of power, and then we can talk about, well, relatively stable efficiency. Of course, it's wishful thinking so far. The same, we would like the combustion engine to work as a generator. However, it changes in the range. Similarly here, which of course, it is the weakest link. Already we've heard that statement today. Thank you, Professor, for mentioning the efficiency of a combustion engine. I'm not sure that everybody is aware of the fact that paying 7 zloty per liter of gasoline, only 30% is well used. Well, now, when we use a vehicle, do we actually look at the efficiency, or do we rather concentrate on functionality? And here a question goes to Professor Marek Brzeżański. As the history of technology shows us, massive use of given type of propulsion is decided eventually by its level of functionality. Professor, you personally participated in tests on using cars with fuel cells in sub-zero temperatures and in tests dealing with fueling hydrogen-propelled vehicles. In your view, how do you see the functionality of this hydrogen propulsion with fuel cells? Ladies and gentlemen, aside of piston engines fueled by hydrogen, we also research vehicles propelled by fuel cells, thanks to the fact that we have a very huge thermoclimatic chamber where we can fit up to 4 big lorries and where temperature can be controlled in the range from +40 to -60 Celsius. We've conducted such research, such tests, operational tests of 2 models of Toyota Mirai. First, Toyota of the first generation, then the second generation model. Now, why in the thermoclimatic chamber? Well, because similarly to piston engines, the startup phase and the warming up phase, this is the critical period also in fuel cell systems from the point of view of operational parameters. Now, what are these critical parameters? First of all, the product of hydrogen changing in the fuel cell is water steam. And it can, of course, freeze in negative temperature. And freezing of steam can quickly result in complete destruction of fuel cell. That's the first aspect. There's also a second aspect, which is often forgotten. In electric propulsion vehicles, we're dealing with high voltage. So when the vehicle is strongly cooled, a thin layer of water is released and covers all the surfaces. And for that reason, we've researched the resistance levels of all these protective elements. We've also tested specific nodes of the propulsion system. We looked at the level of voltage, whether there are actually any jumps due to the cover with this thin layer of water. Very interesting results were obtained. Among others, for the first time in Poland, we've had tests regarding use of hydrogen in high startup at a temperature of -20 degrees Celsius. How does the warming up phase go? How does it develop? Can the engine be used right away at full power? What does the operation of the engine looks like later when external temperature changes? These are tests which have to be conducted before massive introduction of such vehicles on the market. Of course, these vehicles are already available, but so far in relatively low numbers. Of course, wanting to introduce serial production of these vehicles, we have to create a certain series of regulations for the user, which are characteristic for this type of propulsion. That's why we've carried out such research. There's such an aspect, which Professor Szałek already mentioned, is the fueling. And we do have certain experiences here, thanks to the kindness of Toyota. I had an opportunity to participate with Professor Szałek in operational tests of Toyota Mirai, which we carried out in Berlin due to obvious reasons, because it's very close to the Polish border. There are a lot of hydrogen fueling stations. So when we were conducting these operational tests in Berlin and in Potsdam, there were 6 hydrogen fueling stations. We visited all of them. They varied. In some stations, the fueling point was separated from the distributors of other fuels. In others, which I was amazed by, the hydrogen distribution was located directly at the distributors of diesel fuel, LPG, and regular gasoline. Therefore, issues of safety were already handled to such a degree which allowed for hydrogen in distribution process not to be a major problem. The procedure of fueling itself is analogous to the procedure of LPG fueling. So in order to get hydrogen at these available hydrogen fuel stations, it's this H2 Europe company. First, you have to go through a quick online training, and after that training, you receive a special magnetic card, which allows you to obtain permission to get hydrogen at these special fuel stations. It seems that this process of training is already under control to such a degree that it allows every hydrogen vehicle user to go through this type of procedure. So I can authoritatively say that the level of construction of modern vehicles propelled by fuel cells and the procedure of fueling these vehicles is already ready. It's here. It can be introduced in wide scale, even in mass scale production of this type of vehicles. Thank you very much. As a user of hydrogen car, I'd like to say that I don't have to change my habits, and I can be sure that I can fuel up in the same place where I fuel up my hybrid car. I can have my coffee there as well. And by the way, this is where hydrogen car producers say that they can be operated up to the temperature or down to the temperature of minus 32 degrees Celsius, which was demonstrated during tests. Now, a question to Director Grzegorz. A maneuvering locomotive is reality. We could follow that in the media, we could cheer in the creation of this type of vehicle. The producers talk about electric railway systems fueled by hydrogen. Please tell us more about this issue. Is that a question of near future, further future? When can we expect to be able, for example, to take such a train to a resort town like in the Hel Peninsula here nearby? What are the challenges here? If I could just refer to what my colleagues from POZNAN in Cracow have said, and I'd like to confirm that in the context of piston engines fueled by hydrogen, we talk with other constantly, we meet, and we are definitely waiting for the moment when we will be able to use such an engine locomotives. So I confirm that it's an overlap of business and R&D. It's there, it's here in Poland, it exists. So we cooperate, we meet, we talk. So greetings, gentlemen. Now regarding the vehicle itself. Well, I'm functioning at this overlap of two worlds. When I sit here as a representative of the manufacturer of the rolling stock, we can talk about hydrogen is unavailable, it's going to be here. However, when I go to a conference dealing with a classic railway vehicles. When there are certain topics connected with hydrogen, then usually I hear from carriers or people dealing with operational topics, they tell me it's senseless, it's not yet time, it's far future, it's too hard. So I live on this overlap of two different worlds. But let me tell it this way, it's reality. The first 14 vehicles propelled only by vehicle, they're already operating in Saxony with passengers. First stationary fueling station was already started. It's functioning. The preferred model is fueling railway vehicles from mobile stations. Probably that's going to look like in years to come. So I wouldn't be afraid of a barrier in Poland in the case of not having vehicles, because these can be our vehicles, because we presume that at the end of 2026 and scaling up this propulsion from locomotive, we'll be able to move it to to passenger train. So everything is this should be quite easily done. But in our case, passenger vehicle 2026, I think. Probably quite sooner our external competition will be able to propose that for Polish market. So I'm not afraid of that. I'm also not afraid of homologation, because in the next 4-6 months, I think this formal legal process will be completed here in Poland. So the procedures allowing such vehicles to be used will be completed. I think it's a little different when it comes to convincing carriers to use it. I think in Pomorski it's not a problem because we have a lot of people supporting it. Hopefully it's going to be our vehicle. The barrier is somewhere else. It's somewhere beyond our industry. It's more in the question of costs. A little bit in the mentality of carriers, but that's changing. But the question of costs, operational costs, is a barrier, because this rolling stock is 30-40% more expensive. Its costs are also 20-30% higher than in case of similar vehicles so far anyway. But what's happening in the West, what we can see, where clients actually come and buy, where the EU subsidies are already in place. We have questions about concrete products. Many states, not just in Western Europe, but also in Central Eastern Europe, are asking about hydrogen vehicles. They want to buy them. They have means, they have finances to do it. And furthermore, many countries are starting to think that we are building a vehicle and its maintenance in the period of 10 years, and the higher costs of maintenance in relation to classical diesel vehicles are partially compensated, which is very encouraging for companies which are carriers, which operate these vehicles later. So this is where I would look for success when it comes to railways, and starting up all these financial mechanisms, subsidy mechanisms, support mechanisms, and finally, education. Not enough of that here. Of course, not here in this room, but in many places in Poland, among colleagues from the industry, from the industry, I hear, hydrogen, that's so dangerous, and so on. So education. So that example of that Zeppelin that keeps coming back, right? Yes. We had a sentence here that we heard that users have to be convinced. Well, I think this is where we're going in this panel. We want to convince certain people. Our experiences show that people are not instantly convinced. Sometimes reflection comes after a while. Now a question to Professor Grzegorz Tchorek. Because transformation transport on the European continent is being spoken of quite intensively lately. So I'd like to ask you whether planned changes and discussion around transformation in European governments, does it support hydrogen in transport? Can we look with optimism at the future here, or should we rather fight harder for more understanding and convince more dynamically about supporting these solutions? I think that if we were not optimists, we wouldn't be here. We wouldn't be talking to each other. No. But a more general statement, talking about fuels. Of course, recently we've had very, very dramatic events in the world which changed our ways of thinking to a degree, but we are at a certain point in time in such a situation which nobody expected, certain schizophrenia. In fact, a year ago, we all wanted to get rid of fossil fuels. Today, the situation is different. We're complaining of their lack. So, of course, I do not support us staying with fossil fuels, but this is an example that we simply have to be reasonable in planning. We are in a period of a short period of time when we're coming back to a little bit of coal. What about natural gas? That's also under a certain question mark. So this whole regulation side, what's happening, and reinforcement of regulations put emphasis on larger investments than were being planned in the previous period.
So underneath what is happening short term, so this sentimental coal resurfacing, it is important that our decision makers also look further ahead and that there is an explosion of technologies with a greater power than we would have expected. If I were to go down to the level of technologies, complementary technologies, that are those related to hydrogens and to battery-related mobility, because they go hand in hand, very often we, not to antagonize the two, we say that they're actually based on the same technology, the same assumption, but there is full consent about that. But we should bear in mind that the characteristics and the features concerning the power, the powering, or the fuel itself, or the storage capabilities differ. And what is missing from our today's market or national ecosystem, or which is not emphasized enough, is the launch of two parallel, regulatory-wise and value-wise, systems of support. On the one hand, for battery technologies, and on the other hand, for hydrogen technologies. As a rule, they play the same role, but they will be complementary in different parts of the ecosystem of transport. So I wouldn't necessarily point at the fact that it is necessary to fight for it, because I think that the awareness at the level of decision makers is pretty high now. We just need to continue. For some time, hydrogen-related technologies used to be perceived as lagging behind the battery-related technology. But I think that today they go hand in hand, and it is the same intensity with which we should promote also the hydrogen technologies. Thank you very much, Professor. We've touched upon an important issue. The battery technologies has been there ever since the beginning of automotive industry. Well, hydrogen has been around for several years. Just a minor digression, but thank you for noticing that. And now, on a serious note, I believe that resources should be allocated, enabling the meeting of zero emission goals, and technologies should be left in the hands of producers, scientists, and their milieux. We still have a moment. Now it appears that we need to be wrapping up. Then a brief question to all of the gentlemen of the panel. The Polish hydrogen strategy and Polish sector agreement mentioned that the implementation of particularly those topics that we've mentioned should be carried out by three types of entities, so scientific milieu, business milieu, and the business support milieu. And I would like to ask each of you for a very short contribution. I will not mention the order, not impose it. What is the state of this cooperation? You do represent all the three areas. So what is this cooperation today? What has it looked like? And are there reasons for us to rejoice, or are we and for challenges? Maybe a brief contribution. This cooperation has not been easy. Each of the stakeholders speaks their own language. Business speaking about fuel cells or hydrogen things. CAPEX, OPEX, KPI. Scientists talk about losses, activation, diffusion losses, and administration generally and broadly understood things about AFI regulations or fire protection issues. So there is an example here of how to make everybody start speaking the same language so that they can mutually understand one another. platinum is used as a catalyst. Well, here we do not need to use it. We can use Polish zloty or euro as a catalyst. And it's, on a serious note, is to be using the resources from the project so as to create an environment for the projects to be implemented within. And the requirement would be the participation of all the stakeholders in such projects. It is not reinventing the wheel, because such projects have been implemented in the European Union, in which one of the requirements is that each of the milieux is represented by stakeholders. So it is only through projects that these technologies can become widespread. I'm optimistic. We've been working together, talking. Resources have been appearing in the market. I think that we will keep on implementing projects with Polish science, a very important contribution. Thank you for that. If I may, German science is at a service. We give a certain offer as science. We show our competences, our research capabilities, but we do not have this agency that will make it possible for us to obtain huge funding for the financing. We are ready to support economic entities in attracting such means. As you know, each project of the National Center of Research and Development should derive from business. We are just an addition that makes it possible to carry out the scientific part. But the Polish science, I think, is ready to take up the challenge, and I think that the result of these activities will be some tangible, implemented hydrogen-related projects. Thank you. Again, if I may, I would like to wrap it up by saying that if we've touched upon hydrogen technologies today, we had representatives of two groups, actually, piston combustion engines and fuel cells. And I think that this first group is more of an evolution towards hydrogen powering, the evolution of the propulsion system. That's my feeling. Whilst fueling fuel cells with hydrogen is more of a revolution. And these two groups need to clash, of course, but I think that both of them, through Polish science, well, they should be supported by the Polish science, and I think they are. Thank you very much. I will not say anything wiser than what you've heard so far. I'm happy that the new formula projects, particularly the European ones, enforces the cooperation of various stakeholders. And I think that that's the source of hope for access to resources and new approach to what we are trying to develop. Thank you very much, gentlemen, for your participation in the panel. You, ladies and gentlemen, for listening to it. Unfortunately, we need to be wrapping up, although we wish we could continue. Thank you very much. Thank you very much for being able to participate. Thank you very much.
Jesteśmy największą metropolią w Polsce Północnej. Jesteśmy otwarci na to, co nowe. Jesteśmy świetnym miejscem do życia. Jesteśmy Trójmiastem i dlatego zawsze będziemy dbać bardziej.
Korki na wszystkich drogach dojazdowych do Trójmiasta już dawno przekroczyły akceptowalny poziom. Dlatego samorząd województwa pomorskiego uruchomił nową linię kolejową łączącą metropolię trójmiejską z Kaszubami. Dzięki podróży pociągiem tysiące osób może szybciej i wygodniej dojechać do pracy, szkoły lub na zakupy, a potem wrócić do domu. Nie trać czasu i pieniędzy w korkach. Podróżuj szybko i wygodnie koleją. Do pracy, do szkoły, na zakupy.